here. We got part 2 on rational expressions here. This time we're talking about adding and subtracting. So just remember, follow along with me. We're going to do about 4 examples. So follow along with me in your notebooks, and then I'll give you a couple to try on your own. All right, so first I got the steps here. You can copy these down if you want, or just kind of check it out. Adding and subtracting rational expressions, which is like adding or subtracting fractions. First thing you're going to want to do is factor the denominators, because that's going to lead you to your second step, which is finding the LCD, or the least common denominator. I put there in italics to write it down because it really helps if you put it somewhere, you can remember that's what you need as a denominator. From there, you need to multiply the top and bottom of each fraction by the missing factors, what it needs to become the least common denominator. Multiply through the numerators. Then you're going to have that LCD at the bottom of each of your fractions, so you can add or subtract the numerators over the LCD. And then lastly, see if you can simplify. Now, a reminder of how we do this is kind of a look back at what we used to do back in the day. All right? Adding two fractions with unlike denominators. The first thing you have to do is determine what is your LCD, what's the smallest thing both of those denominators would multiply up to get. And you could multiply them both up to get 15 pretty easily, right? That's the smallest thing that you'd multiply them both to get. So then you ask yourself, all right, what do I need to multiply each by to get that? On the left here, I need to multiply the 5 by 3 to get 15. So I multiply it by 3 over 3, because that's 1, and that doesn't change the value of it. On the right fraction, I need to multiply by 5 over 5 to get 15 as the denominator. Now when I multiply the numerators together, I get 9 over, denominators together, 15. And then when I multiply again the numerators together, I get 5 over, again, 15. With the same denominator, I can just add or subtract the fractions. 9 minus 5 is 4 15ths. Final answer. You should check if you could simplify there, but if not, you're good to go. Those are the same steps we're really going to follow for something even a little bit trickier like this, okay? So first thing I want to do is factor the denominators to see if I can break it down at all. And these, I don't need to, right? They're basically in factored form. There's nothing I can really do to it. So I want to determine what's the least common denominator. So it must exist in both of these two denominators. So my LCD is going to be 2x squared. The reason it's 2x squared is because I can see it's pretty easy to get to 2x squared by multiplying simple little things to each of the bottom. For example, this one. I want to get 2x squared, and I've got 2x, so I multiply it by x over x, and that'll get me my LCD on the bottom. Same thing over here. I want to multiply just x squared. I have to multiply it by 2 to get 2x squared, so I multiply by 2 over 2. So up top, I got 5 times x is 5x over 2x squared, plus. Now here it gets a little trickier. Notice this is a binomial here, x plus 7. So if I multiply 2 times that binomial, x plus 7, I have to distribute the 2 in. So it's going to be 2x plus 14 over 2x squared. And notice now I've got the same denominator, so I just add across. Now this is a plus sign, which is nice, which means I can really jump to just combining like terms, right? So really, in case we're not sure where that exactly is coming from, I'm basically looking at this all over my denominator. So when I add those together, I see that 5x and 2x can combine, and that 14 is just kind of left on its own. So 7x plus 14 over 2x squared. Now, a last step that sometimes comes into play and sometimes doesn't is seeing if you can factor and simplify, just like you would any other fraction. Just like simplifying 4 over 6. I would want to simplify that to 2/3. I want to see if I can simplify this fraction. In order to simplify, I notice that I can factor something out of the top. So 7 is going to factor out and be left with x plus 2 over 2x squared. So I've got factored form on top and bottom, and nothing's going to cancel out. Remember, you can't cancel those two x's because x plus 2 doesn't cancel with just an x. They're different, right? So my final answer is that I leave it in factored form just to prove that, hey, I showed. I checked to see if I could cancel stuff out, and I couldn't. All right? So just one thing to keep in mind. There's a fine line between the numerator and denominator. Literally. Get it? Oh, that's good. In case you don't, only a fraction of you will understand this, so don't worry. A fraction? That's good. That's good. All right. We got two more examples we're going to run through, so let's check them out, and then you're going to get some to try on your own. First step is factor the denominators. We didn't have to do it in the previous problem, but I do now. So I see the bottom of this denominator, 2x minus 3. I can factor a 2 out of that. I'd be left with, 2x minus 6. I can factor the 2 out to get 2 times x minus 3. Same thing, x squared minus 9. This is the difference of two squares. Be sure, always be on the lookout for that when you get two terms, the difference of squares or the sum or difference of cubes. This is two things squared subtracted, so they're going to factor into x plus 3, x minus 3. All right, now is the tricky time. I got to find my LCD, and we're getting a little tougher. I'm going to write it separately so I can always go back to it and see what's going on. My least common denominator is the smallest thing that they both like multiply up to get. In other words, I need to include the factors of the two denominators in there, all right? So my least common denominator is 2 times x minus 3 because that is this denominator. I know that needs to be included. It's got to be a part of the LCD, right? So I've got that, and then I also need to have this be a part of the LCD, right? I already have the x minus 3 accounted for right here, so all I'm missing is the x plus 3. Let's do it. This is my least common denominator, okay? So you got to go back and say, all right, that's my least common denominator, so what do I need on the left side? What am I missing? I am missing x plus 3, right? That's the one part that's missing from my LCD. So I multiply this fraction by x plus 3 over x plus 3. Okay? Same thing on the right now. I want to figure out what's missing from this denominator. It's just the 2 that's missing. So I multiply it by 2 over 2. Okay? So what I've done now is on the left, I'll just stay right here. On the left, the denominator is the least common denominator. It is the 2 times x plus 3, x minus 3. Keep in mind, the order doesn't matter. The coefficients generally go in front, so I kept the 2 up there. But it's got all three things. That's what matters. So now what goes in the top? Distribute. 5x plus 15. Okay, minus. On the bottom, again, I've got the LCD, x plus 3, 2 times x plus 3 times x minus 3. Up top, I, again, have to distribute the 2 into both. So 4x plus 10. All right, now I got the least common denominator on the bottom. The one thing I want to look out for is the fact that I'm now subtracting these two things. So to subtract, I'm essentially doing another distribution. I'm distributing a negative here and a negative here. Turns these both into minuses, all right? So now, I've got the common denominator, 2 times x plus 3, x minus 3. That's my denominator. Up top, then, I want to combine like terms. I'm going to jump right to it. The 5x and the negative 4x gets me just 1x, or x. The 15 and the negative 10 gets me plus 5. Awesome. Now I should check, can I factor and can't fill anything out? Nope. Final answer. Done. Very cool. One heads up, if I wanted to, because why not, it's kind of fun, you can also list your restrictions. What would x not possibly be equal to? What x value would go here or here that makes the fraction undefined, meaning the denominator 0? Your restrictions are x equals 3 and x equals negative 3. Okay? All right, one last example. Time to get to the tricky ones. Boom. Lots and lots of stuff going on, but hey, we can do this, no problem. Follow the same steps. We want to determine our least common denominator first. So I want to factor the two denominators. After playing around with it a little bit, I know that I'm going to factor this into, it's going to be a 2x here and an x here. And if I do minus 4, that turns into negative 8x plus 3. Boom. So that's my factored form of that. Awesome. This one is nice, easier, little level 1 factoring. So I know it's x and x plus 5 minus 4. Cool. Got it factored, and I am hoping, and most of the time, 99% of the time, there's going to be one factor in common between the two denominators, and luckily there is one here. So my LCD then has to contain both denominators. So I'm going to start with this one, 2x plus 3 and x minus 4. So got that accounted for. Well, I've already accounted for the x minus 4, so the only thing I'm missing is the x plus 5. So my least common denominator here has 3 binomials in it, which is okay. It's just going to take a little more work, but that's all right. Now, check it out. See what's missing, okay? On the left side, I'm missing my x plus 5, so I'm going to multiply by x plus 5. Right? On the right, I'm missing the 2x plus 3. So I multiply by 2x plus 3 over 2x plus 3. Boom. Okay. Now, on the bottom, I'm going to save myself some time because I know I've got the LCD here. I need to multiply these two binomials together. So you might have heard of this called FOIL, or it's just distributing two binomials to each other, right? So, boom, boom. First, outside, inside, last. All right, so we get 3x squared minus 2x plus 15x and minus 10. Lots going on. Minus. Let's do it again. I'm going to leave it as LCD just because I don't feel like writing all that out a million times. And again, we've got two binomials multiplied together, so I do FOIL. First is 2x squared plus 3x minus 4x and minus 6. All right. Checking. Looks good to me. Okay, now it gets a little tricky because I got to remember, again, I'm subtracting all this stuff. Okay? If I want to save myself a little time, I could combine like terms here. So I'm going to combine the 3x and the negative 4x to just be negative x. Right? Then I'm going to combine the negative 2x and the positive 15 into b plus 13x. Cool. Now I'm going to extend the page and finish this guy off. Combine like terms. So I got a negative 2x squared, a positive now x, and a positive 6. Combine like terms, we get 3x and negative 2x gets me x squared. 13x and x gets me 14x. And then negative 10, positive 6 gets me negative 4. Awesome. I'm going to put my LCD now in here because I'm thinking I might be at my final answer. X plus 5, 2x plus 3, x minus 4. Notice I named these three in a different order than I did originally because it doesn't really matter. It's multiplying the numbers together, so it doesn't matter which one comes first, second, or third, as long as they're all together. The question is, can I factor this? Something that multiplies to get negative 4 and adds to get 14? No, I'm not going to be able to factor it. It's a good thing to check, but in this case, can't do it, so we've got our final answer right here. All right. That finishes off our examples. Here's a couple for you to try. See how they go. Follow the examples we did before. Pause it. And there are your answers. All right. Good work. Hopefully this helps you out. See you guys out there.